Function calls are a fundamental mechanism in programming that enable modularity, reusability, and clarity in software development by allowing a programmer to break down complex tasks into smaller, manageable components. A function call occurs when the program execution transfers control from the main program or another function to a defined block of code known as a function, which performs a specific operation and may return a value. This process begins when a function is invoked using its name along with any required arguments or parameters. When a function is called, several important operations take place in the background. First, the current state of the program, including the location of execution and necessary data, is saved so that control can return after the function completes. This information is stored in a stack frame, or activation record, within the call stack. The call stack is a crucial data structure that maintains a last in first out (LIFO) order of function calls, ensuring that the most recently called function is the first to complete execution and return control to its caller. Each stack frame typically contains the function's parameters, local variables, return address, and other bookkeeping information. When the function finishes executing, it may return a value to the calling function using a return statement, after which the stack frame is popped from the call stack, and control resumes at the exact point where the call was made. Function calls are central to the principle of abstraction, allowing programmers to hide complex logic within reusable modules and invoke them through simple interfaces. They also support recursion, where a function calls itself repeatedly until a termination condition is met. Recursive function calls are heavily dependent on the call stack, as each invocation creates a new stack frame. This makes recursion powerful for solving problems such as tree traversal, factorial computation, and divide and conquer algorithms, though it must be used carefully to avoid stack overflow. Function calls also play a key role in parameter passing, which can be done in different ways depending on the programming language. Pass by value creates copies of arguments, while pass by reference allows a function to directly modify the caller's variables. Moreover, function calls are essential for modular programming, enabling large software projects to be divided into independent units that can be developed, tested, and maintained separately. In object-oriented programming, function calls take the form of method invocations, often involving message passing between objects and supporting concepts like inheritance and polymorphism. Modern programming environments also rely heavily on function calls for system operations, library usage, exception handling, and event-driven programming. Function calls provide structure and flow to programs, enabling hierarchical design and improving readability and debugging. Overall, function calls are indispensable to programming because they enhance organization, reduce redundancy, improve efficiency, promote code reuse, and provide the foundational mechanism by which control flows between different parts of a program. Without function calls, managing complex logic or developing scalable, maintainable software systems would be extremely difficult, highlighting their crucial role in both low-level computation and high-level program architecture.